Okay, so in the previous videos we've learned about logarithms and have been introduced to logarithms, specifically dealing with the base of 10. And in the previous video, in lesson 9.6, we saw some application for logarithms and some different story problems dealing with decibel levels and earthquakes and a Richter scale. Today we're going to look at logarithms to bases other than 10. Because you can see, like from this example, that we're going to have bases other than 10. We're not always going to have just a base of 10. So there's got to be a way to do these. And really it's very simple, especially since we're already familiar with common logarithms. Now what I have highlighted here, I want to make sure that you understand. Because there's going to be times where there's going to be something written in logarithm form, and we need to change it to exponential form, or vice versa in order to solve it. My hint that I always give students is that if you're ever stuck on a problem and don't know what to do, try changing the form that it's in. So if the form is currently in logarithm form, try changing it and putting it in exponential form. Or if it's in exponential form and you're stuck, try changing it and putting it in logarithm form. The majority of the times, I'd say 9 times out of 10, that's probably where not your mistake, but where you're stuck at, that's going to get you the solution that you're looking for. Now here's an example where like I said, we have a base other than 10, where I have 3 to the 5th equals 243. We can rewrite this in logarithm form to say it's going to be a logarithm. Remember, your base is the number that has an exponent, so your base here is going to be 3. So it's going to be log base 3 of the value 243 equals, and logarithms are always equal to exponents, so our exponent here is 5. So another way to look at it is, if I was just given this problem, log base 3 of 243, and I was asked to solve it without a calculator, what I would do in my head is I'd try to figure out what exponent I'd apply to 3 to get 243. 3 to the 4th power is 81, so 3 to the 5th power would be 243, so my answer would be 5. Now sometimes you're going to be asked to do things like this, where we have an equation, and we need to rewrite it in logarithm form. Now I want to really emphasize this, because I see students make this mistake all the time, where they try to simplify this by multiplying together the 9 and the 1.028. You can't do that. The reason why you can't do that is because of this exponent. This exponent only applies to the 1.028. It does not apply to the 9. And order of operations tells you that you need to apply the exponents first before doing any multiplying. So since I can't apply this exponent of x, I can't multiply the 9 times 1.028. So I'm at a standstill. I can't do anything. So in order to work through this, what I need to do first is this. I need to get rid of this 9. So I'm going to divide both sides by 9. That's your first step. Your first step is to get the base by itself. And if you're wondering what the base is, look for the exponent. The base is always attached to the exponent. So we want to get that 1.028 by itself, so I divide both sides by 9. So now I'm left with p divided by 9 equals 1.028 to the x power. My next step is to rewrite it in logarithm form. So remember, my base is a number that's attached to the variable, or to the exponent. So even though it looks weird, you're going to have a logarithm sometimes of some weird numbers. And so this time your base is 1.028. So it'll be the logarithm of 1.028 of the value, which is p divided by 9, which equals your exponent, which is x. Since I don't know what p is, there's nothing more I can do with this problem. If I had known what p was, I just plug that in here and can find out what x would be. So why don't you guys take a second and pause this video and work this next problem out and hit play when you're ready to check your answer. But you're going to follow the same steps as example 1A. So what you should have done here is start out by dividing both sides by 12. So this time I have p divided by 12 equals 0.359x. Again, don't forget, we can't multiply the 12 and the 0.359 together. So my next step is to rewrite this in logarithm form. So this time as a base of 0.359 of p divided by 12, whatever that would be, equals your exponent, which is x. There's your answer. This is going to be some of the more common problems that you're going to see in your assignments and on a quiz or a test where you'd have to do all of these without a calculator. So why don't you take a minute, make sure you get all these written down in your notes if you haven't printed this out, and so that way you can follow along best when we go to try these. Okay. So let's look at this first one. So again, we're trying to figure out what the exponent is that we'd apply to 7 to get 49. Well, 7 squared equals 49. So that means your answer would be 2. So let's go down to D. We'll go counterclockwise starting with A because B is going to be the most trickiest one. So let's look at this one. This one, again, you're trying to figure out what exponent you'd apply to 2 to get to 16. Well, you might have thought of that. 2 to the 4th power would equal 16. Again, you're not trying to figure out what times 2 gives you 16. It's not 8. It's what exponent would you apply to 2 to get 16. And in that case, 2 to the 4th power, oops, why did I write 18? 2 to the 4th power would equal 16. So your answer here would be 4. Now let's go to the next one. This one's a little different. It's 6 to the what exponent would give you the square root of 6? Let's see here. 6 to the what power would give you the square root of 6? Well, if you remember, back in Chapter 7, when we learned about radical form, we also talked about exponential form, and we said that the square root of 6 would be the same as 6 to the 1/2 power. Well, now, I want to figure out what exponent I'd apply to 6 to get 6 to the 1/2 power. Well, it should be pretty obvious that it would be 1/2. That's your answer. Each of these are getting gradually trickier and trickier. Let's look at the next one. Here we're trying to figure out what exponent we'd apply to 3 to get 1 over 81. Well, this one looks really weird. How would we do this one? Well, let's think about this for a second. Here my base is in the numerator, but the 81 has moved to the denominator. Can you think of what we've talked about in the past that would make it so I'd have to move this 3 to the denominator? Maybe you've come up with it, but it's if we have a negative exponent, remember we'd move the 3 to the denominator. So now I know that my exponent's going to be negative. Now I just need to figure out what exponent I'd apply to 3 to get 81. Well, 3 to the 4th power is 81, so that means 3 to the negative 4th power. If you think about it, I move that down to the bottom, so it becomes 3 to the 4th power, which is 1 over 81. So my answer would be negative 4. So again, if you have something like this of a fraction with a 1 in the numerator, you're trying to figure out what exponent you'd apply to 4 to get 1 over 64. Well, just remember, well, it's got to be negative because we're going to move it to the denominator. And 4 cubed would give me 64, so my answer is going to be negative 3. Let's look at this last one. I want to figure out what exponent I'd apply to 8 to get 2. Look what we got here. Here we had an answer of, we went from applying an exponent to 7 to get 49. Here we're trying to figure out what exponent we apply to 2 to get 16. Over here we try to figure out what exponent we'd apply to 3 to get 1 over 81, or we looked at it as 81, and 4 to 64. So if you notice, we're applying exponents and the numbers always get bigger. Think for a second, what kind of exponent would actually make our number get smaller? Now, it wouldn't be negative numbers, because if I had a negative exponent, that would actually make it into a fraction. Maybe you came up with this, but it should be a fractional exponent, or a root, because I'm trying to figure out what root I'd apply to 8 that would give me 2 as my answer. And the cubed root of 8 gives me 2. So my answer here would be 1/3, and I might be saying, I don't know that I could have done that on my own. How can I figure this out? When I know that I have a root problem, or trying to figure out what root I'd apply to a number to get 2, sometimes I'll work my way backwards and try to figure out, well, 2 to what exponent would give me 8? Well, since 2 cubed gives me 8, going over to the 8 now, I take the opposite of that. It would be the cubed root, or to the 1/3 power. So sure enough, the cubed root of the 1/3 power of 8 is going to be 2. So these are going to be the trickiest ones. Now, as far as your CAS calculator, the CAS calculator will allow you to change the base of your logarithm to be any base that you need. Scientific calculators will not do that for you. There's a special trick you have to do if we want to simplify something that has a base other than 10, which we learn about, I think, in the end of this chapter. But the most important thing is to know how to do these without a calculator, like examples 3 and 4 here. These, again, they look tricky. Log base 4 of h equals 3 halves. You might be saying, I don't know what to do here. Well, if that's the case, remember, like I always say, if you're ever stuck, try putting it in a different form. It's currently in logarithm form. Try putting it in exponential form. See if that changes anything for you. We learned about that in a previous section. Remember, a little trick my teacher taught me was you could take the base and slide it over, so we'd have h equals our base, which is 4. Our exponent's going to be 3 halves. Going back to chapter 7 again, where we have to simplify this type of problem, we want to break this up into the root and the power. So the root here would be the second root to the third power. So the square root of 4 is 2, and 2 cubed is 8. So my value for h would be 8. Again, what we did is we took our base, slid it over, so I had 4 to the 3 halves power. You take that exponent, break it up into the root, which is the denominator, and the power, which is the numerator. So the second root of the square root of 2, the square root of 4 is 2, and 2 cubed is 8. So my answer would be 8 here. Let's try the next one together. So again, slide the exponent over, so it's going to be, to find a, it's going to be 81 to the 5/4 power. We're going to break that up into the root, and then the power. Well, the fourth root of 8, trying to find what times itself, 4 times would give me 8. Well, that's going to be 3. And if I know that 3 to the 4th power is 81, 3 to the 5th power would be 3 times that, which we talked about at the beginning of this lesson, is going to be 243. So that's how you do those situations where we have the log of with a base of a value that I don't know equaling our exponent. Change it to exponential form. What about this one? Find w if the log base w of 1024 equals 10. This time I know my exponent's 10, but I don't know what the base is. Still, if you're stuck, put it in exponential form. So I'm going to take my base, which is w, drag it over, so now I have 1024 equals w to the 10th power. Now this also we learned about back in chapter 7, and that's to solve for w. I'm going to raise each side to the, I'm going to take the 10th root of each side, or you might think of it as the 1/10th power. Either way is fine. If you take the 10th root of 1024 or take 1024 to the 1/10th power, you get the same answer, which is going to be 2. So you'd have w would equal 2 in this case. Or for this one, again, we're stuck, so I'm going to slide the base over, so it's going to be z to the 3/4 power equals 8. So we put it in exponential form. So now I want to get rid of this exponent of 3/4, so I'm going to take and raise each side to the reciprocal of 3/4, which is 4/3, and see if that helps. Sure enough, these cancel out, so I'm left with z equals 8 to the 4/3 power. So I'm going to break this up into the root and the power. So this would be the 3rd root of 8 to the 4th power. Well, the 3rd root of 8 is 2, because 2 times 2 is 4, times 2 would be 8. Now I want to figure out what 2 to the 4th power would be, and that would be 16. So my answer would be 16 there. So the most important thing to know today for this lesson is the fact that if you're ever stuck, if you ever have something in exponential form, put it in logarithm form, or if it's in logarithm form, put it in exponential form. So hopefully you have an understanding of what we're doing in this lesson, and good luck on your assignment.